Hi, this is John Isles and welcome to Geometer's Paradise. Today I want to talk a little bit about angle classification. This is the traditional idea that we have three different types of angles. We have right angles, we have acute angles, we have obtuse angles. We also have a classification called a straight angle and another one called a reflex angle, which you almost never hear about, but it's nice to talk about it when you're adding angles and all of a sudden their sum is greater than 180 degrees. What we're going to talk about today, though, is a number of constructions to show when an angle is right or acute based on Euclid's definitions from his book Elements. And it all begins with the idea of perpendicular. And he said, when a straight line standing on a straight line makes the adjacent angles equal to one another, each of the angles is right, and the straight line standing on the other is called a perpendicular to that on which it stands. That's pretty crazy, but basically it means that if you take a straight line like this black one that you see here, and you stand another straight line on it like this red line here, and the angles on either side are congruent, then we say the red line is a perpendicular to the black line, and that the angle formed on either side is a right angle. After the right angle, Euclid defines two more types, the obtuse angle and the acute angle. Here you see two line segments, AB and CD. Euclid says that an acute angle is any angle that is less than a right angle. So if I were to draw a ray here, then this angle plus this angle is equal to the right angle, which means that this angle is less than the right angle using the angle addition postulate. If I come over here and I draw a ray here, then the obtuse angle is equal to the right angle plus an acute angle. The right angle is less than the obtuse angle, or we say that the obtuse angle is greater than the right angle. I'd like to show you the right angle construction. One way to do it is to start with a point and then draw a circle around the point. By starting in this way, rather than drawing a line or a ray, what we do is we create a circle that we can use to guide our construction. And that keeps all the points the same distance away from A and makes life easier for us later on if we're trying to do like congruent angles or something like that. Anyway, I've drawn ray AB, and now I'm going to draw a perpendicular line using the perpendicular line tool through A to AB. So here's our perpendicular. If I intersect the red line and the green circle and then draw a ray AC, then the resulting angle is a right angle. Alright, let's look at one of our guided practice problems. Here we want to show that angle BAC, which is 72 degrees, is going to be acute. And we're going to do that by building a construction in GeoGebra. Start by plotting point A and B, and then defining an angle of a given size by clicking B, then A, and then 72 degrees. As you can see, I've already done this once. So connect the dots and rename so that this is angle C, and then we see, alright, 72 degrees, here's angle A. We draw a perpendicular line to either AC or AB by clicking on A and then the side of the angle. Place point D on the perpendicular and draw a ray AD, and then DAB is a right angle. DAC plus CAB is equal to DAC by the angle addition postulate. Alright, now we want to get our construction into Word, so we move and resize our window, and then Control-Shift-C to copy, paste it into the correct spot by pressing Control-V, and then resize your picture so that it fits neatly in the window. Alright, now let's fill it in. By the angle addition postulate, we know that angle DAC plus angle CAB is going to be equal to angle DAC. using the rules for inequality, our original angle, angle CAB, is less than angle DAC, which is the right angle. And since DAC is a right angle, angle BAC is acute.